Sanjana, here I've given break for 5 minutes because we just now finished the physics class. Okay, so I'll be starting the class somewhere around 6:20.
Okay, sir.
Okay. நிறைய பேசிட்டோம். Class time ஆயிடுச்சு. But we'll talk. In between we'll talk. Permutation, combination வச்சு பேசுவோம். I think others are feeling bored. Yeah? புரியுதா ஏதாவது பேசுறது? Any other business aspiration in this room? இல்ல என்ன பண்ணோம்? ஏதாவது பிசினஸ் ஆஸ்பிரேஷன் இருக்கிறவங்க படிச்சா போதுன்றியா? டாக்டரா? Sorry, I didn't get you. What did you say? You want to become? You are from which group? Computer science? You are from commerce. Actually, I thought you are from science, but I didn't know. You check your application. Yeah. See, those who are online are able to hear me?
Yes, sir.
Yeah. So I just wanted to check. I heard that miscellaneous problems were solved yesterday from linear inequalities, right? Like I mentioned in the previous class itself, that chapter is very easy, right? And I hope you could understand the problems from it and you could solve it. Right. So that is why I wanted to start with the next chapter, that is permutation and combination, which is important. Right. But before that, I want a confirmation from everyone. Shall I proceed, or is there any question from linear inequality? Shall I proceed? I mainly wanted from those who are online. Here I got my responses.
Yes.
Yes, sir.
Yeah. Shweta, you also right? You're fine.
Yes, sir.
Okay, done. Okay, we'll get started with this. We got shut down, huh? What happened? Why is it showing like this? Right? Yeah. So shall we get started? Yes. So the next chapter that we are going to see is chapter 6, which is called as permutations and combinations, right? It's a very simple chapter, but tricky here and there in understanding a question, right? So let's try to make our fundamentals strong before we get into the so-called formulae or problems, okay? So first, let's try to understand why this chapter is all about. Like, why do we even need this chapter, or why do we need those formulae that we are going to discuss in the chapter, right? So you all use passcode, right? For your mobile. How many of you use Google Pay or Phone Pay? Of course, you're not eligible, no? Mobile. Okay. So, okay, let's take this mobile. So you use passports, right? Just to unlock, right? So how many digits do we have? You can either have 4 or 6, right? You'll have these two combinations. Suppose I take your phone, let's say there are 4 digits that I need to enter and I need, then how many such combinations can I try?
Excuse me, sir.
Yeah.
Sir, you're actually presenting linear inequalities chapter.
Is it so? 1 minute. Now is it visible?
Yes, sir.
See, what are all the possible digits that you are going to enter? Anywhere a number between 0 to 9. There itself you have 10 numbers. In those 10 numbers, this first space can take how many options? 10. So this can take how many options? This one 10 and this one will take 10. So if I ask you to try that combination, see, for 3 unsuccessful things itself, it will get logged. That's a different thing. But how many options are possible if you try it in this way? It is going to be 10 into 10 into 10 into 10. Basically, it is 10 power 4, which is going to be 10,000 options. How many did I write? Correct? I wrote an extra 0. Okay. So you have 10,000 options that are possible. Is the point clear? Right? So is it something worth sitting and trying? All right. So we need to understand how did we arrive at this 10 power 4? That is what this chapter is all about. How did I even tell you that you have? I didn't add them. I actually multiplied them. So why we did this kind of a multiplication when it comes to the count is what we will learn. From there, we will try to derive a formula out of it. So there will be a separate formula for permutation and there will be a separate formula for combination. Okay. So you need to understand what is permutations in the first place. Permutation basically refers to arrangement of things. So what does it refer to? It refers to arrangement. Whereas combination refers to selection of things. So permutation refers to arrangement and combination refers to selection. Okay. So wherever there are problems or there are questions where they say arrange in a particular format, right? Then you need to think of permutation. Whenever they say select, we need to think of combination. You have some few more keywords also that I'll tell you when we come to the problem. I'll tell you how you're supposed to pick them, right? So the first thing that we are supposed to see is something called as fundamental principle of counting, right? Here there is a very basic example. Okay. So let us consider the following problem. Suppose there is a person named Mohan who has 3 pants and 2 shirts, right? So how many different pairs of a pant and a shirt can he dress up with? Can directly tell. 3 pants, 2 shirts. How many ways can he dress up? 6. How did you say that 6 directly? Because 3 into 2, right? But the question is, if you try to classify things and look at it, what are all the different options that can be possible? Let's see. See, what are all the different options that are possible? Can you tell me? So I'll write it in terms of ordered pair. So for pant, I'll use the symbol P and shirt S. So P1, S1, P1, that's it. Similarly, P2, S1, P2, S2. Similarly, what about this? P3, S1 and P3, S2. That's it. So these are all the different kinds, combinations that can be taken into consideration, right? So that's what they've given. Let us name the pants as P1, P2, and P3, and the 2 shirts as S1 and S2. Then there will be 6 possibilities that can be illustrated using the figure 7.1, which is going to be this. So pant 1 can be combined with shirt 1 or shirt 2. 2 can be combined with shirt 1 or shirt 2. 3 can be combined with shirt 1 or shirt 2. We wrote the same thing in terms of ordered pair. I hope you could understand, right? The next question is, there is a problem statement like this. A school bag can be chosen in two different ways. A school bag can be chosen in two different ways. After a school bag is chosen, the next step is you need to choose a tiffin box that can be chosen in three different ways, right? So how many such combinations are possible for you to select? If I ask you to select a school bag and a tiffin box, in how many ways can you do that? Actually, I think there is a statement before this. See, this is. Let us consider another problem of the same type. Subnam has 2 school bags, 3 tiffin boxes, and 2 water bottles. In how many ways can she carry these items? In how many ways can she carry these items? So a school bag can be chosen in 2 different ways. After a school bag, a tiffin box can be chosen in 3 different ways. So how many possibilities are there? There are 6 pairs of school bags and tiffin box itself. Then what is the third option? Water bottle. Yeah, that water bottle thing is there, no? So if that is also to be chosen, then how many possibilities will be there is what the question is. How many water bottles are there? 2. So how will you write the option? So basically, can you write it as a triplet? So what is the triplet I'm talking about? Bag, I'll call it as B. For bag, we'll use a symbol B. For tiffin box, T. And for water bottle, W. So can I write it like this? Bag 1, tiffin box 1, and water bottle 1. Similarly, bag 2, T2, water bottle 2. So like this, can I keep writing the option? Or I can do one thing. B1, T1, W2. So I'm first finishing with B1, T1, B1, T1. So W1 and W2 alone, I'm changing. Then what can you write? B2, T1, W1. B2, T2, W2. So you're done with B1 and B2. Now all that you need to change is keep changing the value of T1, T2, T3. Like that, if you write it, no, you will get all these combinations. You will get these options. So how many possibilities of this sort are there? Basically, there are 12 possibilities. Every time we cannot sit and write it like this. Right. See, here the numbers are simple. It is only 3, 2, and 2. So it was simple. At least 12 combinations you can write and see, but not every time it will be possible. If it goes to 30, 40, 50 and all, it will be difficult, right? So for that, we need something called as a mathematical operation or an arithmetic operation, which directly tells us the answer. And that is what is given by this fundamental principle of counting. So basically, when we say fundamental principle of counting, right, what we do is, right? So in the fundamental, you solve these kind of problems, the fundamental principle of counting, or simply it is also called as multiplication principle. Though we call it as principle of counting, we don't add them. We actually multiply them, because that is how the outputs, when you write it in a elaborated way, is telling and matching with that multiplication. Is that clear? So it is what it is called as the fundamental principle of counting, or simply the multiplication principle itself. So what does it state? If an event can occur in m different ways, following which another event can occur in n different ways. So what do you mean by event here? Doing a task. In the previous case, what was the event? Choosing a bag, choosing a tiffin box, and a water bottle. So these were all the events, right? So if an event can occur in m different ways, following which another event can occur in n different ways, then what are the total number of ways in which both the events can occur? It is going to be not m plus n, rather it will be m into n. Okay, and this is what is called as the fundamental principle of counting, or multiplication principle. Right? Suppose instead of 2 events, if you have 3 events, what are you supposed to do? It is going to be, let's say the third event can occur in p number of ways. Then it is going to be m into n into p. Like that, how many other events you have which are going to happen subsequently, for you to complete all those events, what are the number of ways it is possible? You just take the number of ways, multiply each. Okay. So this is what the example has told. If an event can occur in m different ways, following which another event can occur in n different ways, following which a third event can occur in p different ways, and the total number of occurrence to the events is given by the order m into n into p. Right? So this is what is called as fundamental principle of counting. So just make a note of it. Okay. Shall I proceed? Copy. See, don't write this part, just write it till here. It's something from your textbook only. If you can copy it from there also, it is fine. Okay. It's there in your textbook. We'll concentrate on the problems. Okay. So look at this problem. Find the number of 4-letter words with or without meaning, which can be formed out of the letters of the word rows where repetition of the letters is not allowed. So what is expected? You need to form a 4-lettered word, right? Using what letters? You need to use the letters of the word rows. So R, O, S, and E can be used, right? R, O, S, and E can be used. So if you take these 4 letters, right, in the first space, 1 minute. Yeah. So in the first space, any of the 4 letters can be used. So can I say that there are 4 possibilities? In the second space, since repetition is not allowed, you already used one of the letters here. So here, how many are possible? 3. And here, how much is it going to be? 2. And here, how much is it going to be? 1. So what are the total number of ways in which you can form the 4-lettered words? It is going to be 4 into 3 into 2 into 1, which is going to be 24. So you can form 24 words. Right. So this is how it works. Can make a note of this. Shall I proceed? So next question is, given 4 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? So the signal consists of only two flags, one below the other, right? Now, how many different colors do we have in our hand? We have 4. So in the upper one, how many flags can you use? 4. Right? You can use any of the 4 colors. Next is here, they didn't mention whether we are going to repeat. So of course, signal means it should not be repeated. You cannot have green here and green here. It doesn't make sense, right? So here, how many colors are possible? It is going to be 3. So how many such signals can you form? According to fundamental principle of counting, it is 4 into 3, which is 12, right? Right.
Sir,
Yeah, tell me, ma'am.
sir, can you explain how it became 4 into 3?
Yeah, you see, because it is of the fundamental principle of counting. The first one is there, no? So here the signal part, the top part of the signal is there, no? How many colors can you use in that particular part? You can use 4 colors. So since out of the 4, you would have used one of the colors, the second one has an option of you using only 3 colors. Is that point clear?
Yes, sir.
So it is 4 into 3 according to fundamental principle of counting. Okay. Next. Example 3. How many 2-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 if the digits can be repeated? So if you observe, you are expected to form a 2-digit even number. So when it is a 2-digit even number, the first check that you need to complete is you need to ensure what is there on the right hand side. So the right hand side out of the numbers that are available can either be 2 or 4. So how many combinations do you have? You can use any of the 2 numbers from the available 5 numbers. So here, how many numbers are possible? 5. So according to fundamental principle of counting, 5 into 2, it is going to be 10 numbers. Right? Basically, if you try to write and see, no, if you fix 2 in the units place, right? 2, 2, 2, 2, 2, 1, 2, 3, 4, 5. Similarly, if you fix 4 in the units position, it will be 1, 2, 3, 4, 5. That's it. So these are the 10 numbers that you can write. Suppose in the same problem, they say that repetition is not allowed. So repetition is not allowed means this number and this number should be eliminated. So you can just make a note of it. If at all they mention that repetition is not allowed, then it will be only 8. What are the numbers that will get eliminated? 22 and 44. Sure. Shall I proceed? Fourth example. Find the number of different signals that can be generated by arranging at least, see, this is where you need to be careful. At least 2 flags in order, one below the other on a vertical staff. If you have 5 different flags, so you have 5 different flags out of which you need to create a signal which consists of 2 flags, one below the other. So 2 flags, it is at least 2 flags. So it can either have 2 flags or it can have 3 flags or it can have 4 flags or it can have 5 flags. These are all the possible options, at least 2, maximum 5. So here, since it's a signal, of course, repetition will not be allowed. So here, how many possibilities are there? How many colors do you have? You have 5. So 5, and here it will be 4. Here it will be 5, 4, 3. Here it is going to be 5, 4, 3, 2. Here it is going to be 5, 4, 3, 2, 1. So 5, 4, 3, 2, 1. If you observe 20 into 3, 60, 60 into 2 is 120. So here it is 120, here also it is 120, here it is going to be 60, and here it is going to be 20. So if at all using the 5 colors, you are only going to design a flag with a signal with 2 colors, then 20 such signals are possible. If you're going to make a signal with 3 colors, 60 are possible, 4 colors, 120 are possible, 5 colors also 120 are possible. Right. So these are all OR options. That is why the answer is going to be 20 or 60 or 120 or 120. So 240, 60 is going to be 300, 300 plus 20 is 320. So you can form 320 such signals using these 5 different colors. There are 320 options possible because they use the word at least. Are you able to understand? See, these problems are simple only. Shall I proceed? Okay. Listen. So example number 4 is find the number of different signals that can be generated by same question. Huh? Okay. So this is exercise 6.1. First question. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4, 5, assuming that repetition of digits is allowed? So in the first case, repetition is allowed. So all that you need is a 3-digit number. So 3 blank spaces. So first, so you can come in any order because there is no condition here. So this can have 5. This has possibility of filling with 5 numbers. This also has 5. So 5 into 5 into 5 is going to be 125. Such numbers can be formed with repetition. Say if suppose repetition is not going to be 5, 4, and 3, which is going to be 60. Right? Next problem. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6? So the expected result is a 3-digit number and it should be even. So for it to be even, this should be taking either 2, 4, or 6. So how many possibilities are there? You can fill it with any of the 3 numbers. So digits can be repeated. So here it is going to be 6, and here also it is going to be 6. So 6 into 6 is going to 36. 36 into 3 is going to give us 108. Right? We can have 108 such even numbers. It should be an even number, no? So out of the available numbers, you can have only 2, 4 or 6 in the units position. Only then it will be an even number, no? So third, how many 4-letter code can be formed using the first 10 letters of English alphabet if no letter can be repeated? So 1, 2, 3, 4. They want you to use only the first 10 letters. So here you can have 10, here you will have 9, here you will have 8, and here you will have 7. So 10 into 9 into 8 into 7. How much? 30. 530. So the answer to this should be 504.
Sir, it will be 5040.
50?
40.
I think 50, yeah, because 10 is there. I'll just correct it for video purpose. So this should be 5040. Right. So fourth question. How many 5-digit telephone numbers can be constructed using the digit 0 to 9 if each number starts with 6, 7 and no digit appears more than once? So you need a 5-digit telephone number and every number should start only with 6 and 7, right? It should start with 67 and no digit appears more than once, means repetition is not allowed. So means between 0 to 9, you have 6 and 7, which is already utilized in these two positions. So how many more numbers are left out? So here it can be 8. See, one common mistake is we write it as 7 here. Because what happens is we'll do 9 minus 2, we think 7 digits are left out, but we forget to count 0. So 0 to 9 are 10 numbers. So out of 10, 2 numbers are utilized here. So here there can be 8 numbers and here it will be 7 and here it will be 6. So it is basically 56 into 6. So 300 plus 36, 336. So it will be 336 such numbers. Clear? How many more are there in this exercise? 5 and 6. Okay. Will I proceed? Yeah. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? So it will be 8. Basically 2 power 3, it is going to be 8. Right. This question comes in probability also. See, it is basically simple. Okay. What are the 8 possibilities? A coin has 2 sides. What are they? Head and tail. Right. So it can be head, 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 tail, 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 or it can be head, head, tail, tail, head, tail, head, tail, head, tail, head, tail. So basically what I did is, out of the 8 possibilities that we have, in the first column, I wrote 4 heads, 4 tails. Second column, I made it half. So 4 by 2 is 2. So 2 heads, 2 tails, 2 heads, 2 tails. In the third column, I made half of this, which is going to be head, tail, head, tail, head, tail, head, tail. So these are all the outcomes that are possible. Is that point clear? Shall I proceed? I have only these questions. So is there any other question also? What is it? Is it not similar to the previous one? Yeah, tell me what is the question? So we have 5 flags of different colors. How? Each signal requires 2 flags, one below the other. Then answer is how much? 5 into 4, that's it. So you need a signal with 2 colors. So this can take 5 and this can take 4. So it will be 5 into 4, which is going to be 20 itself. Right? Next. So next we'll get started with the permutations part. Okay. So topic we are going to discuss is
So you're not
permutations.
using the screen.
Right. So here, when we talk about permutation, permutation basically means arrangements. Right? Permutation means arrangement. So now what we are going to do is we'll try to derive the formula for different scenarios. Like in the previous case, you saw, right? Like there was an example where we saw that using the letters of the word rose, we had to form 4 different, we had to use those 4 letters and form a 4-lettered word, whether it has a meaning or not. But what is that? What is expected? You should not use the words. Sorry, you should not repeat the letters. Right? You should not repeat the letters. Right? Is there a way where we can solve the same problem instead of fundamental principle of counting? Do we have a direct formula that can be used? Is what we are going to see. Okay. So even before I get into the concept of formula, the first thing that I need to tell you is about factorials. So there is a concept called as factorials. So where factorials says that if you have a positive integer, if you have a positive integer, and for that positive integer, let's say you need to find n factorial, right? Then it is written as n into n minus 1 into n minus 2, so on till 1. Meaning, you will start with n. N should be multiplied with the next number, one number below it. It should be multiplied with n minus 1. It should be multiplied with one number below it, n minus 2. Like that, what should be the last number with which you need to multiply? You need to multiply it with 1 and then stop it. For example, if I have 3 factorial, the meaning of this is going to be 3 into 2 into 1, which is going to be 6. Similarly, I have 5 factorial. It is going to be 5 into 4 into 3 into 2 into 1. So 6, 24, 24 into 5 is going to be 120. Are you able to understand? So this is how it works. So this is what is called as factorial. Right now, you can ask me a question, why do we even need this? Right? So to understand why we need this, we need to take this and apply it in the permutations. Right. Shall we proceed? So if you observe this, number of permutations of n different objects where you take R at a time, taken R at a time, right? So taken R at a time, where R is going to be a number greater than R is going to be a number greater than 0, but less than or equal to n. The meaning of this is, I have n distinct objects in my hand. How many objects? N distinct objects in my hand. Out of those n distinct objects, I'll take only R objects, where that R can vary anywhere between 0 to n, where 0 is not included. You cannot say that I will not take any object. You need to take at least one object and arrange it. So I'm giving you R spaces, right? I'm giving you R blank spaces into which actual option, how much did I give you? I gave you n distinct objects. So R refers to places, blank spaces, right? And n refers to the number of objects. So using those n objects, you need to fill these R blank spaces where repetition is not allowed. Repetition obviously cannot occur because n are different objects. Okay. So how will you do it? So I'll just explain it again. Number of permutations of n different objects taken R at a time, where repetition is not allowed. So what will be the answer for this? Answer is, tell me. Here, how many ways can you fill this blank space? N, because I giving you n objects. Here, how many can you put? You can put n minus 1. Here, how many can you put? N minus 2. In a similar way, in the rth blank space, it is not 1. If it is 1, then you have n blank spaces. If it is going to be 1 here, means you have taken, then here you can get 1 only if you have n objects and n blank spaces. It is not n minus r. Observe. For first number, I have n minus 0. For second number, for second blank space, I have n minus 1. Third blank space, I have n minus 2. So for first blank space, so here it is the blank space and the number. Observe. So first blank space, how much do I have? N minus 0. Basically, can I write this n minus 0 as n minus of 1 minus 1? Second blank space, how much do I have? I have n minus 1. Can I write this as n minus of 2 minus 1? Right. Third, n minus 2. So here can I write it as n minus of 3 minus 1? So what is happening is this number and this number are matching. In a similar way, in the rth blank space, what will I have? I'll have n minus of r minus 1. You should not write it as n minus r. So I will have n minus r minus 1 options. So according to the fundamental principle of counting, how many ways can we complete this? We can complete this in n into n minus 1 into n minus 2 into n minus 3, so on till n minus of r minus 1. Is this point clear? No, n minus r plus 1. or n minus of r minus 1. Is this point clear? Now, what I need to do here is, I want to bring in the concept of factorial. So if I have to bring in the concept of factorial, what I need is, I need to start with n. I need to continue the multiplication, and where should I stop? I should stop when I have 1 at the end. But I don't have 1 here. I have only n minus r plus 1. So I keep decreasing the number by 1 unit. Right? If this is n minus r plus 1, observe what I'm going to do is, can I write the next number as n minus r? This is something that I'm doing extra. Observe. I'll write that in a different color. So this is going to be n minus r. What will be the next number? N minus r minus 1. What will be the next number? N minus r minus 2. It keeps on going till, can I stop it with 1? But what I did is, this is not a part of this at all. It is something that I multiplied. So I need to compensate it. So it is going to be n minus r into n minus r minus 1 into n minus r minus 2, keeps on going till 1. Now, if you observe, I started in the numerator, I started with n and ended with 1. So putting everything together, can I call this as n factorial? In a similar way, in the denominator, I started with n minus r and I ended with 1. So I'll call this as n minus r factorial. Basically, whatever you did here using the fundamental principle of counting, you got this result. By doing a mathematical manipulation, we could write the same expression in terms of factorial. So how did we write it as n factorial divided by n minus r factorial? And this is what is called as NPR. This is what is called as NPR, where n is going to be the n different objects you have in your hand. R is going to be the R items that you're going to take one at a time. And this is going to be the formula to solve the problem where there is no repetition. Is this point clear? Are you able to understand this? Okay. I'll just give you an example and then you can copy it. See, if you look at the first problem that we solved in the previous exercise, we had the letters of the word rows 1, 2, 3, 4, four blank spaces. How many 4-lettered words could we form? 4 into 3 into 2 into 1, right? Where repetition was not allowed. So here what is going to happen is, you have 4 letters, you have 4 objects, that is what is n. 4 times p, what is going to be r? R is also 4 because 4 blank spaces. So it is 4p4, which is going to be 4 factorial divided by 4 minus 4 factorial. So 4 minus 4 factorial is 0 factorial. So 4 factorial divided by 0 factorial. Remember, 0 factorial is 1. Okay, why is it so? You need not, as of now, I'm not explaining it, but 0 factorial is 1. So answer is supposed to be 4 factorial. So what is 4 factorial? 4 into 3 into 2 into 1, 6 into 4, it is going to be 24. Check if that was the answer, obviously. Because you will get the same thing, 4 into 3 into 2 into 1. You're able to understand? So basically, this formula is extracted by manipulating the fundamental principle of counting. So that is the base of this chapter. Am I clear with this? Just make a note of it. Permutation? Yes, if repetition is not allowed, then you use NPR. If repetition is allowed, there is another way to solve it. N is a superscript, P is in the middle, R is a subscript. Okay. So you go to page number 106 in your textbook. I don't have a. There's your book only. Yeah. So go to page 106 in your textbook. There are some example problems asking you what is 5 factorial, 6 factorial. And revised book other. This is the revised book. Other page. 140. Yeah. So if it is old book, go to page 140. If it is revised book, go to page 106. Do you have some example problems? Just do it quickly. Just do it fast. You have the chapter binomial theorem or deleted it? Let me check. I'll do it parallelly. You can check the board. So example 5. First question is find 5 factorial. 5 factorial is going to be 5 into 4 into 3 into 2 into 1, which is going to be 120. Second, find 7 factorial. So 7 factorial is going to be equal to 7 into 6 into 5 into 4 into 3 into 2 into 1. So this is basically what? That is 5 factorial. So it is 7 into 6 is 42. 42 into 5 factorial is 120. So 120 into 42, how much are you going to get? So you're going to get 5040, right? And the third question is Third question is 7 factorial minus 5 factorial, right? See, one of the common mistakes is 2 factorial. No, you cannot take the factorial outside 7 minus 2. You cannot write it like that. 7 factorial is 5040 minus what is 5 factorial? 120. How much are you going to get? 024920. Right? So if you observe example 6, we need to compute 7 factorial divided by 5 factorial. 7 factorial 5040 divided by 5 factorial is 120. So this is going to give us the answer as 42. Because it is very simple. See, 7 factorial is there, 5 factorial is there. Bring the 5 factorial this side. 7 factorial by 5 factorial is 7 into 6, which is 42. Right. Next. The second one is compute 12 factorial divided by 10 factorial into 2 factorial. Okay. So 12 factorial is going to be observed. I want you all to observe this problem. Listen. Whenever you have the highest numbers factorial, right? Check for the numbers which are lesser than that. So what is that? You have 12 and you have 10 factorial. No, so 12 factorial, how you can write is 12 into 11 into 10 into till 1. So can I write this as 12 into 11 into 10 to so on? Can I write that as 10 factorial itself? Divided by, this will be a 10 factorial into 2 factorial. This and this will get cancelled. So 2 factorial is going to be 2 into 1, which is 2 itself, right? So 12 into 1, 11 divided by 2, which is going to be 66, right? Which is 66. Clear? Shall I proceed? So if you look at example number 7, right? If you look at example number 7, evaluate n factorial divided by n minus r factorial into r factorial when n is equal to 5 and r is equal to 2. N is equal to 5 and r is equal to 2. So take this and substitute it here. It will be 5 factorial divided by 3 factorial into 2 factorial. So 5 factorial, I can write it as 5 into 4 into 3 factorial divided by 3 factorial into this, I can write it as 2 factorial. So 3 factorial and 3 factorial are gone. 2 factorial is 2. So 2 will cancel this 4 2 times. So 5 into 4 is going to be 10. Okay. So basically, this n factorial divided by n minus r factorial into r factorial is called as NCR. So we use P for permutation, C for combination. So this, about this, we'll see it in the last exercise. Is it clear? As of now, you can make a note of it. The difference is, if it is only n factorial by n minus r factorial, it is NPR. If it is n factorial by n minus r factorial multiplied with r factorial in the denominator, then it will be NCR. They both appear to be similar, but that is the difference. Okay, just one question. Observe. What is this part n factorial by n minus r factorial? It is NPR. So this, can I write it as NPR divided by r factorial? This is also same. So these are the different ways in which we can connect NPR and NCR. Okay. So throughout this chapter, we are going to learn about these equations only and where to use what. Shall I proceed? Now, if I go to example number 8, the question is, if 1 by 8 factorial plus 1 by 9 factorial is equal to x divided by 10 factorial, then find x. Right? So how to solve this? Among these three, which one has the highest factorial? 10, no. So what you can do is you can write this as 1 by 8 factorial. The least factorial, leave it as it is. The second highest is 9 factorial. No, you write that 9 factorial in terms of the least factorial. So you write it as 9 into 8 factorial is equal to x divided by 10 into 9 into 8 factorial. So basically what happens is 8 factorial gets cancelled. So 1 plus 1 by 9 is going to be 10 by 9 is equal to x divided by 90. So this will go 10. So x will be 100. Is that clear? Clear with this? Okay. So one last formula that I'll give you is exercise. I'm leaving it to you. I think you can solve it. It's the same kind, similar problems. Okay. If we have n different objects taken r at a time, okay. If there are n different objects where r are taken at a time, where r are taken at a time, and there is no repetition, then what are the number of ways in which the objects can be arranged? N PR, which was given as n factorial divided by r factorial. Okay, this is when there is no repetition. If at all there is repetition, then what will happen? 1, 2, 3, 4, 5, so on till I'll have r blank spaces. So since the objects are allowed to be repeated, how many objects can be placed in this? N. How many can be placed in this? So on till r times. So according to the fundamental principle of counting, how many ways are possible? N into so on till n. How many times? R times. So answer will be n power r. Is that clear? So when the objects can be used again, when there is repetition allowed, it will be n power r. When repetition is not allowed, it will be n PR. Is it clear now? Right. See, actually, we have done this in the previous exercise also. But the only thing is we didn't derive it like a formula and do it. According to the fundamental principle of counting, it will be, I think there was a problem, no? The 3-digit number. Something was there, but where we wrote the same kind, 2 power 8 is for the head and tail. 3 power 3. 3 power 3, 5 power 5. 5 numbers were there, 1, 2, 3, 4, 5. 125 answer. That example, I don't remember. 5 power 3. Answer was 125. Is that clear? So again, one more disclaimer is this chapter is also small, almost 60. Actually, I've taught you all the concepts. Only thing is we need to know how to apply it in problems. The only concept which I didn't explain is here, if you see, the objects are different. Sometimes there will be a possibility where the objects are same. At that time, how to handle it? That is one kind of a problem, which we will discuss it during the exercise part. Right. So 6.2, I'm expecting you to solve it. 6.3 and 6.4 will be done by next week. Then we can go off to binomial theorem. So these chapters are small. The time will take again with calculus part. So from straight lines onwards, it will take some time. So these are all very small ones. Sequence and series will also take some time. Sequence and series. Basically, last year you would have learned no arithmetic progression. AP, GP, and main other end. Who's book yours, sir? Yeah, those are online. I hope you got clear. You could understand.
Yes, sir.
Okay. So
Yes,
complete
sir.
that 6.2. Next week we'll complete 6.3 and 6.4. Okay. So I'll see you guys next week.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah. Yeah.